Right, that, my friends, is a blown up centre diff out of a transfer case. Hello, I'm Brad from KLR Automotive, and today I want to save you money. And I'm going to do that by explaining what a centre diff does and why you need to look after it. Right, before I explain what actually happened here, what I want to do is show you what an actual working centre diff looks like. Now, pretty much any constant forward drive vehicle needs a way of splitting the drive more or less evenly between the front and rear axles. Traditionally that's been done with a centre diff. This is a centre diff out of an LT95 gearbox, but it's a very, very similar setup in the later LT230s and even into some of the later transfer cases again. Now, basically power comes in, high range, low range gear, and this whole assembly turns. You know, as you're driving, that's just rotating. This was actually very revolutionary back in the day, constant forward drive in a passenger vehicle. Very, very good thing as it turned out. But what we also have, and this is where the magic comes about, that's a rear output shaft. So that's transmitting power to the rear prop shaft. And you can see I can turn that independently of the centre diff itself. And at the front, we have a similar thing, a front output shaft. That goes in, and again, that can rotate independently. It's this independent movement that allows that centre diff to take up small differences in speed or distance or circumference, however you want to explain it, between the front and rear axles. Now those slight differences in speed come about from slightly different tyre size or the front axle has to travel a greater distance than the rear axle when you're going around a corner. So there's just those little factors. That's what the centre diff's meant to do, that's what it's designed to do. So most of the speed is in this whole assembly rotating at road speed, but the individual output shafts themselves aren't really moving at different speeds to each other under normal driving. And you can see there, I'm turning the back one, front one's turning, that's all doing what it should do. So that's as much detail as I really want to go into there. Diffs are actually a fascinating thing, but what I want to do is show you what the inside of one looks like, and you'll start to get a better understanding of what's happened here. So here we have a well-worn but still repairable LT95 diff centre. Now we've already pulled this one apart and had a bit of a look. It is rebuildable, which is actually tomorrow's job. One thing I'll point out, this is LT95, but an LT230 centre diff is almost identical on the inside. So first of all, this is one of the output gears or side gears that people call them. And what I want you to have a look at here, I'll just turn it around a little bit. It's not a big gear, they're not huge teeth. This spline here is what the rear output shaft goes into. So that's what's finally transmitting the drive out to your prop shafts. So all the drive is going through that. However, that's not usually the bit that breaks. Next step down we have the planetary gears, and these sitting here turning away. Now these are the gears that when I'm talking about turning at a small speed to make up small differences in road speed between the front and rear axles, these are the gears that are turning. And these are the gears that normally let go. What you've also got, they run on their own little shafts. Quite a common failure point is eventually they can snap in half. And then finally when you pull it all out, you've got another output gear on the bottom side. Now, if you already know what the inside of a centre diff looks like, some of you might have spotted what's missing in here. What we normally have is these little brass shims, and they sit behind the planetary gears, and that's what actually preloads this centre diff up so there's no backlash or no slop in there. But if these gears spin too fast, these eventually wear away. And you can see in this one, there's no sign of them whatsoever. They've just disappeared altogether. When that happens, these gears can move back and forth like this. And what then happens, once they start doing that, under excessive load, they ride up on the edge of these teeth and everything starts to break. And that's how we end up in the scenario like we have over here, where teeth have smashed off all those gears. Most of those teeth ended up coming out in the gearbox oil, and you lose drive. Now, I can almost hear you all asking, well, if this is designed in here to only turn at low speed, when or why would it ever turn at high speed? And that is the whole point of what I want to talk about today. Let's have a look at our centre diff so I can explain what is actually going on when you start using your centre diff lock. So you'll remember me earlier showing you the output shafts on this centre diff and how they could rotate almost independently of the diff itself, which is what they're designed to do. But there are times when we want to lock that action, and this is where your centre diff lock comes in. Now your centre diff lock is essentially just a sliding locking collar, or locking dog some people call them, groove on the outside for the selector fork, on the inside some relatively coarse teeth to allow easy engagement. Most of the time that just sits, if I can line it up, on the front of your centre diff, so it sits there, that's its normal relaxed position, and you can see the front output shaft can still rotate independently as it normally would. However, when we want to lock that action out, that just slides forward, and now we have the front output shaft locked to the centre diff, and you can see that can no longer rotate independently. We now have a locked centre diff, and we have locked drive all the way through between the front and rear axles, and we've negated the movement of all those little centre diff gears. They're locked solid now in position, so they can't wear out. Now, as I was saying, looking at bits and pieces on the bench is great, and it is helping you to understand what's going on inside your vehicle. But of course you need to see it on the ground, and what I want to do is run you through a series of driving simulations here so you can get a better understanding of what's happening with your diff lock engaged and with your centre diff lock disengaged. So far, we've been talking about the speed at which your centre diff gears have been rotating. Now, in a more practical sense, once we apply that to a vehicle, a better term to use is traction. If you have equal traction at each wheel, your centre diff is actually doing very little. Now, when you're driving on the road or a hard packed surface, you have equal traction at each corner. Your centre diff under those conditions is actually doing very little. But let's have a look what happens when we break traction at one wheel. So what we're doing here is jacking up one front wheel. We still have the centre diff lock disengaged, and Tommy's going to attempt to drive off. So let's have a look at what's going to happen. All of the power of the engine has gone straight into that wheel, and it's just simply sat there spinning. So this is the same as if you'd lifted a wheel up in the air going through some ruts, or if that wheel was in a boggy, soft, muddy patch, or a bit of slippery gravel on the road, something like that. But you can see, under those conditions, your little centre diff gears are going to be turning at exactly the same speed as that road wheel, and we don't want that. What we're going to do now is leave that wheel jacked up in the air. Tommy's going to engage the centre diff, and he's going to try to drive off. So as you can see there, the vehicle actually tried to drive forward. Now that's because the centre diff is locked. So those little side gears are locked out of action. They can't do anything. The action of the centre diff itself is completely negated. So we have equal drive between the front and rear axles. And that is how you want to drive this vehicle whenever you're likely to lose any sort of traction at all. So I want you to picture this scenario. You're out in the middle of Whoop Whoop in the back of New South Wales, Queensland, doesn't matter. You're on a fast gravel road doing 100 kilometres an hour with your caravan on the back. You're running a ball weight of about 300 kilos, maybe a little bit more. That's making the back of the vehicle sit down. Now when that happens, the front of the vehicle is actually lifting up because you're taking weight off the front axle. This means you're also reducing the effective traction at the front wheels, and you can have a scenario where your front wheels are spending the whole day at 100 kilometres an hour scrabbling for traction. That is overspinning the gears in your centre diff. So our rule is, as soon as you hit a dirt road, you need to engage your centre diff lock. You don't actually need to slow down, just push the clutch in, dip the revs, engage your centre diff lock, and away you go again. And we say that for two reasons. One, there is no real upper speed limit at which you can't use your centre diff lock. And secondly, the sheer nature of a slippery gravel road will compensate for any axle speed differences that you might come across. That's pretty much all I wanted to talk to you about today. But I do hope you understand how important your centre diff lock is. Constant forward drive is a great thing to have, and you can't have it without a centre diff, and with a centre diff comes a centre diff lock. Now it's important to take care of that centre diff. They're very expensive to overhaul, and parts are becoming hard to come by. So when you're on a hard packed surface on the road, make sure it's unlocked. When you hit a dirt road or loose surface, you're going to lose traction, make sure you lock that centre diff before you lose traction.